Okay, here we're going to look at what happens when you cannot integrate a function. So we've learned a lot of different integration techniques, but there are some functions that you just simply cannot integrate. And if that happens, what you can always fall back on are Riemann sums, which are both left and right bound, as well as a midpoint rule. And then we're going to learn a new rule today, which is, I think, probably the most accurate, which is the trapezoid rule. Okay, so we're going to review Riemann sums and midpoint rule, and then learn the trapezoid rule. And the whole idea of revisiting these is to round out our study of integration, just to look at what happens when a function we cannot integrate. So let's suppose that we wanted to integrate the following function, y equals x squared. And I'm going to change this integration to make it a little bit easier. We're going to integrate it from 1 to 5. So we're looking at this integration here from 1 all the way to 5. And when we do that, we're going to use both left hand and right hand sums and a midpoint sum. So the following. And we're going to do it with n equals 4. So first of all, we notice that since we're integrating from 1 to 5, the base that I'm looking at in total is 4. And since I'm going to have 4 rectangles, if I look at my base, 4, divided by the number of rectangles, 4, each rectangle is going to be of width 1. Okay, so let's actually start a new page for this. If I were to do, you know, what I might want to do beforehand is just get a picture of all these values. So I could say x and y, and x equals 1, 2, 3, 4, up to 5. And since we're looking at x squared, we have the corresponding values. So if I was doing a left hand and I generated these points, here's 1, I'd go up over to 2, and I would be using my left value to generate the height. So 1 times 1, and then I would go up and over to 3 using my left hand value, which was 4. So plus 1 times 4 plus 1 times 9 plus 4 times 16. So again, the idea here is that we're using the left-hand point to generate my y values. And what do we get? Well, 1 plus 4 plus 25, which is 30. What if I used a right bound? Well, if I used a right bound, my value is going to be bigger, and that's clearly visible because my function is increasing. So if I were to use a right bound on my first rectangle, instead of starting at the left here, I'm going to start at the right. So you can see all the additional area. So now I'm going to be using these values here. So 1 times 4 plus 1 times 9 plus 1 times 16 plus 1 times 25. And now when we add this all up, we get 54, a significantly different estimation than before. And that has to do with the fact that our rectangles are pretty wide. What about if I wanted to do a midpoint? Well, if I wanted to do a midpoint, I'd have to calculate all the y values that were at the midpoint. So I would have to do 1 times f of 1.5 plus 1 times f of 2.5 plus 1 times f of 3.5 plus 1 times f of 4.5. So again, 1 is the base of each rectangle, and then these values are the midpoint values, the y values in between the points. So just to draw a quick little picture of that, we're talking about this. So if this is 1 and this is 2, then we're using the midpoint where this y value is f of 1.5. Okay, so that's something that we've done before, this idea of left bound, right bound, and midpoints. What about the trapezoid rule? Well, the trapezoid rule, let's do the same thing, integrate from 1 to 5 of x squared dx. And we need to make sure that this is going to fit on the graph. So let's increment by 3s. And we go 1, 2, 3, 4, 5. So if we put in all of our points, oops, got to be careful that. Okay, so we've got 4, 16, and 5, 25. So here's our quadratic. What the trapezoid does is it creates a bunch of trapezoids. So it takes the left point and the right point, creates a trapezoid, and then finds the area of that trapezoid. So let's do different. And you can see already, just in drawing this, how significantly more accurate it appears to be. And, well, what we need to do is remember the area of a trapezoid. So if we call this the width, and this height 1 and height 2, the area is the average of the two heights, so 1/2 h1 plus h2 times the width. So if we were to add up all of this, this equals, and let's have, so we have 1/2, and now using my, well, 1/2 f of 1 plus f of 2 times 1 plus 1/2 f of 2 plus f of 3 times 1 plus 1/2 f of 3 plus f of 4 times 1, and then lastly plus 1/2 f of 5, or sorry, f of 4 plus f of 5 times 1. And if we were to expand this, what we get is 1/2 f of 1 plus 1/2 f of 2 plus 1/2 f of 2 plus 1/2 f of 3 plus 1/2 f of 3 plus 1/2 f of 4, and see if you can start figuring out what this pattern ends up being. Okay, so now what we can do is we can say, well, if we were to rearrange this, so I'm going to highlight all the things that I'm going to put to the left. So 1, 2, 3, 4. I'm going to move all those to the left, and I'm going to move the following to the right. 1, 2, 3, 4. What I end up getting, if I pull out of 1/2 is 1/2 f of 1 plus f of 2 plus f of 3 plus f of 4. And those are all the yellow values. Plus f of 2 plus f of 3 plus f of 4 plus f of 5. And those are all the green values. But what's the yellow and what's the green? Well, this trapezoid rule, what it really is doing is it's averaging the left and the right bound. Because this is 1/2 times my left sum plus my right sum. So it's the average of the left sum and the right sum. And that is the quick way of doing the trapezoid rule. It's just calculate the left sum, right sum, and then average them. Okay, so if we try to look at this or summarize this, the idea is anytime you're doing the trapezoid rule, and when you're creating a trapezoid, you've got one height, you've got another height, and you've got some base. So the area is 1/2 the base times the sum of the two heights. And really what's going on is this 1/2 and the sum of the two heights is just finding the average height. So it's taking a trapezoid and it's treating it really like a rectangle with an average height. So let's see an example of that. Okay. It says the velocity of an object moving in a straight line was measured at regular intervals with the following results. Use the trapezoid rule to estimate how far the object traveled from t equals 0 to t equals 1. Well, we're gonna use the left hand and right hand and average it. And then we're going to see a even cleverer way. So what we said is that using the trapezoid rule, it's going to be the left sum plus the right sum divided by 2. So in this case, we're looking at a base of 0.25. So it's going to be 0.25. And our left sum is going to be 1 plus 1.3 plus 1.8 plus 1.6. And our right sum is going to be 1.3 plus 1.8 plus 1.6 plus 1.4. And both of these terms are getting multiplied by our base of 0.25, and then we divide that by 2. So this is my 0.25 times this is my left sum, 0.25 times this is my right sum, and then I divide it by 2. Well, let's think about really what's going on here. If we were to simplify this, whenever you're dealing with a data table like this, the simplest way to do it is to think of it as, well, we have 0.25 times 1 plus 1.3 plus 1.8 plus 1.6 plus 1.3 plus 1.8 plus 1.6 plus 1.4 all over 2. Well, let me do some rearranging now, just like I did before. This is 0.25, 1 plus 1.3 plus 1.3. So I'm just putting the like ones together. Plus 1.8 plus 1.8 plus 1.6 plus 1.6 plus 1.4. So notice that every single term is repeated except for our last terms. And this is all divided by 2. Well, therefore, what we can do is we can say this equals our base, 0.25, times 1 over 2. So I'm dividing this 1 by the 2. And then since I have two 1.3s divided by 2, this is just 1.3 plus 1.8 plus 1.6 plus 1.4 divided by 2. So the idea is you can just add up all of the middle terms, and then you add the endpoints divided by 2. And that comes from thinking about the average of the left bound and the right bound. So to summarize that, let's say that I have the following points, 1, 2, 3, 4, 5, and y of 1, y of 2, y of 3, y of 4, y of 5. My base is 1, so the trapezoid rule is going to result in 1 times my first value over 2 plus my second plus my third plus my fourth and plus my last value divided by 2. So this is the trapezoid rule. So it's a little bit better than certainly better than the left and the right, and it's a little bit better than our midpoint sum. And so the idea of the trapezoid rule is that we just average the left and right hand sums. So let's just do one more example. It's the graph of the function over the interval 1 to 7. Using the values from the graph, find the trapezoid rule estimates for the integral. And what we're going to do is do it for n equals 3. So if n equals 3, we've got, this is a distance of 6. 6 divided by 3 is 2. So we're talking about that and this and this. So what we can do really quickly is the trapezoid rule will result in an area that's 2, and that's our base, times, here are my endpoints, and in red are my repeated points. So it's going to equal 1 over 2, rather, sorry, because our endpoints are over 2, plus 4, plus 6, plus 4 over 2. So again, this is my base. My endpoints, we divide by 2. And then you've got your middle values. And this produces the average value of the left hand and the right hand sums. This is a general formula just to look at if it's any interest to you. And that's it. That is how you can calculate an integral that you cannot integrate. And that ends our study of evaluating definite integrals. And in the next unit, we will start looking at applications of those. Cool applications.